Hello viewers, welcome to the another session in postgraduate diploma in environmental and occupational health. Today we are going to discuss about another factors in the course MEV 003, that is environmental law and then management. In this today we are going to discuss about the management of water, some of the treatment technologies. So as such we have studied the air quality. Like that the water quality is also available and also most important. So how can we define the water quality? So the chemical as well as physical and biological characteristics of water we have to check. Usually in respect to its suitability for designated use, that means drinking or the irrigation purpose or for household activities. So the higher the water quality, the more applications are. So it can also be used within the minimal treatment technology using. So water resources which are of major environmental, social and economic value, and if water quality becomes degraded, so this resource will lose its value. So water quality is closely linked to the surrounding environment and also the surrounding land which is in use. So it is measured by determining the contaminants and also the characteristics of the water, that is the properties. So some water quality indicators are also there which can be employed to understand the quality of water. So that those indicators may be aesthetic, that is a color, odor as well as the floating matter which is present, and then biological indicator that may be types of microorganisms, whether it is a fecal coliform bacteria or not, and also cryptosporidium, sporidium, and also physical measurements like temperature, turbidity and then clarity, color, salinity, suspended solid particles and dissolved solids. And if you will see the chemical indicator, normally we will employ the pH and dissolved oxygen DO, and then biological oxygen demand, nutrients like nitrogen and then phosphorus, and also organic, that also may include toxicants, metal toxicants, and some salts in the form of, that is a sodium or chloride, potassium, calcium, manganese. Not only that, the radioactive aspect also we will see to indicate the water quality, that is alpha, beta and then gamma radiation emitters. So treatment is required for the wastewaters or the sewage waters. So wastewater or the sewage waters, normally they will generate from the household activities and also the industrial waste or the animal waste, and sometimes it is a runoff as well as the groundwater infiltration. Generally wastewater is a flow of used water from the neighborhood. Normally neighborhood may be household, neighborhood may be an industry. So the wastewater that normally contains 99.9% of water by weight, in which the remaining 0.1% is suspended or dissolved materials. So this solid material, which is a mixture of maybe excrements or the detergents or food leftovers, grease, oil, salts, sometimes a plastic material, sometimes a heavy metal contamination, sand as well as grit. So there are so many types of wastewaters are there, like municipal wastewater, industrial wastewater, or the mixture of industrial and domestic wastewater, and agricultural wastewaters, like that. If typically agricultural industries, if we will look into that, that is our dairy processing industry, meat processing industries, as well as juice as well as beverage industries and slaughterhouse, vegetable processing facilities, and also the drainage water of irrigation system. So there are so many industries as well as the agricultural activities. So it is necessary to treat these wastewater before releasing into the atmosphere. That is the most important concern of the human beings. So subsequent to primary treatment of wastewater, that is a physical treatment of wastewater, it still contains large amount of dissolved as well as the colloidal material that must be removed before discharge. So this issue is how to transform the dissolved materials or the particulate matters which are too little for the sedimentation into larger particles to allow the separation process to eliminate them. Ultimately, we have to transform them to eliminate in good condition. So, this can be carried out by the secondary treatment, that is the biological treatment. So, the treatment of wastewater, that is a subsequent to the removal of suspended solids by microorganisms like algae, fungi and then bacteria. So, maybe it is under the aerobic or the anaerobic conditions. During during this treatment, the organic matter in wastewater is oxidized or incorporated into cells that can be eliminated by the removal process or the sedimentation, normally call it as a biological treatment. Another treatment is there, that is a chemical treatment or the tertiary treatment. In chemical treatment, many chemical materials will be using that will react with the portion of the undesired chemicals and heavy metals, but a portion of the polluting material will remain unaffected. In addition to that, the cost of chemical additives and the environmental problems of disposing large amounts of chemical sludge, that makes this treatment process is very deficient, we can say that. So, what is the alternative? So, alternative method is biological treatment that has to be implemented. So, this treatment process normally implements naturally with the help of the naturally occurring microorganisms to transform the dissolved organic matter into dense biomass that can be separated from the treated wastewater by the process of sedimentation. So, in fact, the microorganism that utilizes the dissolved oxygen matter as a food for themselves. It is very surprising fact and interesting fact also. So, once it is absorbs the dissolved organic matter as food, then the generated sludge will be far less for chemical treatment. So, in practice, the secondary treatment that tends to be a biological process with chemical treatment which is implemented for the removal of the toxic compounds. So, what are the goals to achieve in this treatment, the treatment of the wastewater? First one is the transforming the materials which are available in the wastewater into secure end products which are able to be safely disposed of into the domestic water, which are devoid of any negative environmental effects. And the second is protecting the public health. Third one is we are ensuring that the wastewaters are efficiently handled on a trustworthy basis, so without any offense. And the fourth one is recycling and recovering the valuable components which are available in the wastewaters, and also affording the feasible treatment process and disposal techniques. And finally, complying with the legislations, acts as well as the legal standards and approval conditions of discharge as well as the disposal. Now, we will discuss some of the useful techniques which can be employed for the treatment of water. Firstly, usage of wastewater stabilization ponds. So, what are those? They are large man-made water bodies in which black water or sewage water, normally otherwise grey water or fecal sludge, which are treated by the naturally occurring process and in the influence of solar light, wind, microorganisms and algae. So, these ponds can be used individually or linked in a series of that is a networking system for the improved treatment. So, there are three types of ponds are there. One is the anaerobic pond, and the second one is the facultative, and the third one is the aerobic. So, each one has a different treatment as well as the design characteristic features. So, these ponds are low cost for the operation as well as the management system, and also the biological oxygen demand and then pathogen removal is very high. But the large surface areas as well as the expert design are highly required. So, this effluent that still contains the nutrients like nitrogen as well as the phosphorus, and therefore, it is appropriate for the reuse in the agriculture, but not for direct recharge in the surface water. So, this treated effluent relatively high quality and also they can be reused in agricultural agricultural activities, that is irrigation or aquaculture, like that. So they are semi-centralized treatment systems which can combined after wastewater that has been collected from the toilets. For the most effective treatment, these ponds should be linked to a series of 3 or more with effluents which are being transferred from the anaerobic pond to the facultative pond and finally to the aerobic pond. So the anaerobic pond is primary treatment stage which reduces the organic load in the wastewater. So the entire depth of this man-made lake is the anaerobic. So solids as well as the BOD removal occurs by the sedimentation process and also the subsequent anaerobic digestion inside the accumulated sludge. So the anaerobic bacteria that convert organic carbon into methane and also through this process normally the removal of up to 60% of the BOD can takes place. So the aerobic and the anaerobic organisms work together to achieve BOD reduction up to 75%. Anaerobic and then facultative ponds which are designed for BOD removal, maybe the aerobic ponds which are designed for the pathogen removal. That means there is a specific ponds for the specific reasons. Next is the aerated lagoons. They are deep waste stabilization ponds in which sewage is aerated by the mechanical aerators to stabilize the organic matter which is present in the sewage rather than the recycling only in only on the basis of the photosynthetic oxygen which is produced by the algae. So the aerated lagoons represent a system of sewage treatment which is intermediate between the oxidation ponds and also the activated sludge systems. So depending on how the microbial mass of solids which is handled in the aerated lagoons are again depending upon the classification, that is the facultative aerated lagoons and aerobic aerated lagoons and also facultative aerated lagoons. So these facultative aerated lagoons, they will treat some of the solids that may leave with the effluent stream and some particles settle down in the lagoon. So because this aeration power input is just enough for oxygenation and not for keeping all solids in suspension. So as the lower part of the lagoons may be anoxic in nature or the anaerobic, while the upper layers are aerobic in nature. They are known as the facultative aerated lagoons. And aerobic aerated lagoons, they are fully aerobic from top to bottom, because the aeration power input is sufficiently high to keep all the solids in suspension besides meeting this oxygenation which is needs of the system. So no settlement of solids occur in these lagoons, and under equilibrium conditions the new solids which are produced in the system are equal to the solids leaving the system. So there is a 100% equilibrium is generated. So in this case the solid concentration in the effluent is relatively high and some further treatment is generally provided after such lagonic system. So if the effluent is settled and the sludge is recycled, the aerobic aerated lagoon in fact becomes an activated sludge or extended aeration type lagoon. If you will see the advantages of the aerated lagoons, they are very simple and robust in nature in operation wise, and the only moving piece of the equipment is being the aerator. And the second advantage is the removal of efficiencies in terms of power input which are comparable to some of the other aerobic treatment methods. And the third advantage is civil construction, mainly that is the earthwork and the land requirement is not excessive. So aerated lagoons require only 5 to 10% as much land as stabilization ponds, and they are used frequently for the treatment of industrial waste. And next procedure is the activated sludge process. It is a biological treatment process that can be used for the suspended growth of the organisms to remove the BOD and suspended solids. So the process requires an aeration tank and a settling tank, and the primary effluent, that is a plant influent, we can say that, is mixed with the return activated sludge to form the mixed liquor. So, this mixed liquor is aerated for a specified length of time. So, during that aeration period, the activated sludge organisms use the available organic matter as food that produces stable solids and more organisms. So, the suspended solids which are produced by the process and the additional organisms that become part of the activated sludge. So, the solids which are then separated from the wastewater in the settling tank. So, these solids are returned to the influent of the aeration tank, that is the return activated sludge. So, periodically the excess solids and the organisms which are removed from the system, that is a waste activated sludge. So, there are number of factors that can be affect the performance of the activated sludge treatment system, that may be temperature and also the returning rates and the amount of oxygen available and the amount of organic matter which is present, and also the sludge pH and waste load, and also the aeration time, and also the toxicity which is present in the wastewater. So, there are so many factors which can influence. And next we will see that operation methods or operation mode. So, it is the operation of the especially this activated sludge process that requires more operation controls than the other treatment process. So, this operator must adjust the aeration temperature, time, and then return rates and the wastewater rates to maintain the balance of food, organisms as well as the oxygen. So, the operators must observe the operation of the aeration basin to check on mixing pattern, type, and also the amount of foam. Normally small amount of crisp white foam we will observe, and the color of activated sludge, normally dark or the chocolate brown, and also the odor. So, with regard to the settling tank, the observations like flow pattern and settling and the amount of types of solids and leaving with the process of the effluent is normally very clean. So, in this process control operations, sampling and the testing are more important more important techniques. So, testing may be, that is the settleability, that is and also testing to determine the settled sludge volume, and suspended solids testing to determine influent, and also mixed liquor suspended solids, and return activated sludge solids, and also waste activated sludge concentrations, and also determination of the volatile content of the mixed liquor suspended solids, and dissolved oxygen, and pH of the aeration tank, BOD and COD of the aeration tank, influent and process of effluent, and also the evaluation of the activated sludge to determine the predominant organism. Next technique is the trickling filters. So, these trickling filters are the conventional aerobic biological wastewater treatment units like activate sludge system or the rotating biological contactors. So, the advantage of all these systems is that they are compact in nature, that means they are applicable in densely populated urban settings also, and that they efficiently reduce organic matter, and also they are high tech as well as the generally require skilled staff for the construction as well as the operation. So, these trickling filters are secondary treatment after a primary setting process. So, they are consist of cylindrical tank and is filled with high specific surface area material like rocks, gravel, and shredded PVC bottles are the special pre-formed plastic filter media. So, a high specific surface that provides a large area for biofilm formation. So, organisms that grow in the thin biofilm over the surface of the media that oxidize the organic load in the wastewater to carbon dioxide and water, and while generating new biomass. This happens mainly in the outer part of the slime layer, which is generally of 0.1 to 0.2 mm thickness. So the incoming treated wastewater is trickled over the filter like the use of the rotating sprinkler. So in this way the filter media goes through cycles of being dosed and also closed and exposed to air. But the oxygen is depleted within the biomass and the inner layers may be anoxic in nature or the anaerobic in nature. So with growing time, the growth as well as the reproduction of the bacteria that results in an increase of thickness of the biofilm layer, particularly at the top of the trickling filter. If the biofilm grows too thick, oxygen is prevented to enter, obviously, and also the anaerobic organisms develop. So the continuous growth and the metabolic waste products of the anaerobic bacteria and the maintenance of the hydraulic load to the filter eventually leads to the fact that the microorganisms near the surface, they will lose their ability to stick to that filter. So when microorganisms fall off the medium and are carried with the effluent, so this process is known as the sloughing. So trickling filters can be combined in decentralized wastewater treatment systems, especially they will use for the septic tanks and the anaerobic baffled reactors, but are also frequently used in the part of the large centralized wastewater treatment plants. So even though the trickling filters are more easily operated and consume less energy than activated sludge process, they have a lower removal efficiency for solids and organic matter. They are more sensitive to low air temperatures and can become infested with the flies and also mosquitoes. So today we have discussed about the wastewater treatment technologies which we have discussed in the environmental law as well as the management. So I would like to conclude with that what we have discussed today, that is a water quality, which is a chemical, physical and biological characteristics of water, and how it will be measured by determining the contaminants and the characteristic features, that is the physical, chemical and biological characteristics of water, and the acceptable and the permissible limits of different substances in drinking water and their possibility health impacts on human beings. We have discussed in this, and the chemical treatment that can be the treatment of water by using the process that depends upon the chemical behavior and the properties of the components which are present in the wastewater. Mostly used chemical treatment process, that is adsorption, neutralization, chemical precipitation, sometimes it is ion exchange as well as the disinfection. And we have seen that the biological treatment methods, that is the removal of suspended solids, that is the organic matter, which by using the microorganisms like fungi, algae and bacteria under both aerobic and anaerobic conditions. So in this process the microbes which are dissolved and suspended organic matter for their nourishment and transform it into thick and dense biomass. So the main advantage of using biological treatment methods is that their end products are stable and non-toxic in nature. It can also remove almost about 95% of the BOD. So mainly used biological treatment methods what we have discussed are the stabilization pond and aeration tanks and activated sludge process and rotatory biological contractors and trickling filters as well as the anaerobic digesters. So with these I would like to conclude. Hope you must have understood, and then we will meet you in the another session. Thank you.